Good afternoon. This is the second video which I am going to present on trees, B plus trees. Now the first problem which I am going to tell you is we need to generate a B plus tree dynamically. That is, the number of records or the inputs in the file will not be known, and whatever be the number, we need to generate a tree. So here I have used two structures. The first structure is the student structure, which has 4 fields, and the next one is a non-leaf node. In non-leaf node, it contains the offsets and keys values. Each non-leaf node can point to 3 particular students. That is, if there are nine students, then their leaf nodes will be 9, and the above level will be 3, and the following above level will be 1. That's how the structure is made. Now the first step which I am going to do here is I am going to read the file. I am going to take 2 file points. One is for the input and the one is for the output, and then I am going to read till the end of file. And then the first step which I am going to do is, since the given file is a comma separated file, I'll separate the name and all the attributes which are for the student. The attributes are roll number, name, and college. So this is how it works. So firstly, I'll take off the name, type, everything, and I'll store off all the student records continuously into the file, the output file. Then after doing that, I have the second loop which iterates until we reach the root node. And what we have done here is we have taken a variable temp, which always becomes count by 3, where the count is equal to the total number of records. For example, let us take, if we have 51 record, if we have 81 records, then first time the value of temp will be 27. That is, at the level just above the leaf level, there will be 27 records. So what I have done is, each time this until the temp value is greater than 0, the loop works. How it actually works is like, it groups each three records into one single set, and then it stores off the non-leaf node accordingly. This second loop works until the temp value is greater than 0. That is, if we have 81 records, the value of temp goes like 81, 27, 9, 3, 0. So this loop works 5 times in that case. Now just let us run and check this out. Now I have 27 records, so I have got all the 27 records in order. Now if I could have 81 records, then I have got all the 81 records. If I have somewhere around 50 to 60 records also, we will get that particular record, and the leaf nodes for the remaining will be left as empty. Now coming to the second program. This is the second program. The second program is to store all the records, wherein in the initial thing we didn't have any page or anything else, but here we have the concept of paging. Here also the student record is same, but we have a leaf page, wherein each leaf page stores 10 student structures. The size of the page is 512 bytes. This is the following information. Each student is 48 bytes. And then each leaf page is 512 bytes. So at most it can contain 480 bytes for students. That is 10 student information it can contain. And then each non-leaf also has 512 bytes, which means it can contain, or it can point to 64 leaf nodes. So it indirectly means that one leaf page can store 64 leaf pages, which in turn can store 640 records. Now in the given file or in the given program, we have given 640 records, and what we are asked to do is that we need to make them into the output file. So this is again simple. I have taken the count at 640, and then I have read all the 640 records, and I have first wrote all of them into the I have grouped each 10 students into one single leaf page, and at a single time I have stored off the leaf page into the file. Now now after storing all the 640, I have taken a non-leaf page which points to all these 640 records in a